Hey, Mike. What's happening?
Hey, it's Flanagan. Uh, Nothing much, just down here in Columbus today.
Cool. In broad strokes, could you kind of walk us through your career so far, like where you started and how you ended up at Axiom?
A lot of people have a straight direction of their career. Mine's been more like you ever seen the meme of the fish in the water that's standing up by the end on the island?
Yeah.
It's been one after another, but I always like people that take probably nonlinear paths in their career. So, once upon a time, I was a nuclear mechanic on a submarine. So did 6 years doing that. So operating nuclear reactors, working on power plants, things like that. After that, I got out of the Navy. I did a couple years as an industrial maintenance technician. So pulled wires, designed control cabinets. Did that for a little while. Decided at some point that I wanted to be paid for my ideas. So as much as I knew, it helped to have a piece of paper. So I went to school, graduated from Cleveland State University with a bachelor's in electrical engineering with controls. Since I lived in Northeast Ohio, had to spend a couple years at Rockwell. I think it's
Right.
pretty standard for any controls engineer in Northeast Ohio.
Obligatory. Yeah.
Yeah. After that, I went to work for a company called Washington Group, where I was put into a power group, and but my passion was always controls. In that first year there, I got nominated as Innovator of the Year when we were doing arc flash studies, and I was doing the same thing over and over again. I figured out that there was code behind the Excel pages and basically turned a 3-month copy paste operation into a 5-minute push button.
Okay. Cool.
So that was pretty cool. But then the controls group asked the power group if they had somebody that knew how to code, and they said you could borrow Mike for a little bit. I never went back to the power group. I ended up working in the controls group doing large projects for the Cleveland Water Department,
Okay.
an Akron Water Department, where I got introduced to GE software. Caught the company that was selling the software, the vendor caught their eye, and they brought me on board. So it was a company called Gray Matter. I was there for about 10 years. Went from PLC programmer to SCADA programmer to an MES programmer to what I would call an OT architect.
Okay.
I was there for about 10 years and then felt like I needed to grow some more and wanted to do something on a larger scale. So, a partner of mine, Patrick Gahan, asked me to come work at PPG with him. So we were there and we spent a couple years designing a global process control system and batching system.
Hmm.
After that project got delayed, Kennametal called, asked if I knew anything about global standardization and things like that. And so they brought me on board for a couple years. COVID hit, they cut back. Went to work for Fine Zilstra for a little bit with Ryan Cahalan. He wanted to start a digital manufacturing group. So went up there from scratch. When they got sold, Ryan and I decided to start our own company, Axiom, where we specialize in digital manufacturing consulting. So it's been kind of I said, the fish to the
Yeah.
standing person. So I went from just a mechanic on a sub to an OT standards manager for corporations.
It's awesome. It's quite the gamut.
Yeah, it's long. Hopefully there's a lot of editing in there.
Yeah. Yeah, that's awesome, man. So, given that experience, in today's manufacturing environment, what's one thing that most people believe or accept as a truth that you fundamentally disagree with? It can be a trend or something that you see that you just think is the wrong direction for.
People think they can buy good reporting software and get good reports.
Hmm.
And lack the understanding of what I call phase zero architecture and control. So they don't understand the need to standardize and harden their data acquisition systems in a way that can scale.
Hmm.
So many people will have Rockwell come in, they'll have Siemens come in, Emerson come in, or name a software company of the month, and they'll say, look at these wonderful reports, and say, yeah, I need that for my company. And then they'll buy it, and then they'll wonder why they don't have reports they can operate off of, because they didn't put the foundation in to acquire the data to populate those reports.
What's the best way that a company can get that foundation in place? Like, is there an easy path, easy on-ramp to standard data for manufacturers?
I would say reporting data, the actual reports, you can call it an iceberg,
Mm-hmm.
right? 20% of it is what you see. 80% of it's under the water,
Right.
right? And so I generally choose to follow ISA standards.
Mhm.
Several of them are in place: ISA 88, ISA 95. Defining what data is, what it does. Um, that structures your data in a way that can be used in manufacturing software effectively. Um, but in general, if you're embarking on this, don't go ask a software vendor what you should do.
Mhm.
What you want to ask is people with manufacturing experience is what you should do. If I ask Rockwell what I should do, Rockwell's going to say buy all my stuff. If I ask Siemens what I should do, Siemens is going to say buy all my stuff. So in a lot of ways, like, you wouldn't represent yourself in a court of law. You get a lawyer.
Yeah.
You should get a manufacturing consultant to represent you against the manufacturing ecosystem.
Yeah. It's a good way to think about it.
Yeah.
For sure. So, I mean, that seems to be a recurring problem for as long as I've been in manufacturing, which is, a while. How do you think about the future of, it seems like the need for good data that you can actually use for getting results, it's only getting more and more important, especially with AI. Like, well, how do you see the future of this? Like, for instance, a manufacturer that doesn't adopt these data standards versus those that do.
I have a term I like to call it RUMS, RUMS. And as I design systems, I use this term RUMS: repeatable, upgradable, modular, and scalable. So as you design these systems, you need to take a look at that. And if you're building anything that doesn't meet those 4 criteria, you're creating a future liability.
Mm-hmm.
You don't want to do everything custom. You'd rather do it repeat so it scales out. So if you don't set it up correctly now, you're going to pay more in time and lost profits later to correct it.
So tying into that, how do you see it with the AI tools that are out right now? It seems like it's easier than ever for small to mid manufacturers to create homegrown solutions. Like, how does that fit into this world? Like, it seems like there's some low hanging fruit that is net positive for manufacturers, but like, where do you draw the line between developing?
I love AI. I use it a lot, but I know what to ask it, and I can validate what comes out of it.
Right.
And again, that goes into if you get yourself a consultant that can ask the right questions, prompt the right questions, and validate the response. So that's where I think, AI can be leveraged effectively. But AI as a back-end tool as well as part of what I'll call the solution set. It helps you qualify the solution set, but it also can be part of the solution set. So you're starting to see it being used instead of regression algorithms and the software being used to compute the answers. You're starting to see AI formulate the answers. And that's probably the best way to put it, because AI is not using what I would call hard math and science in getting its answers.
Right.
So it may give you an answer, but how do you know if it's hallucinated or not?
Yeah. Probabilistic versus deterministic.
Fantastic. Couldn't have put it better. So AI is part of the solution set, but it isn't the solution set yet.
Right.
In my opinion, I'm happy to be proven wrong. I've been proven wrong in the past as technologies change. So, but it is the wave of the future.
Yeah. What are some of the examples you're seeing right now of actual tactical AI that's net positive for manufacturers?
I'm seeing a lot of AI being used in software configuration. So people are selling software tools that have AI helping you set them up and configure it and lead you through it. Mm-hmm. So you don't need the experts necessarily to come in and deploy the solutions. Or, hey, I want to add this equation to my manufacturing execution system. Do I have to pay somebody $200 an hour to do this? Or can I tell AI, hey, I'm looking to do this. How do I do this?
Right.
So I'm seeing a leverage that way. I'm seeing it structure the data. How do I structure the data? And it's leading that way. It's doing a lot of the menial lifting. A particular use case I had to go through probably 1,000 screenshots to develop a complete I/O list for a system. This sounds a lot like when I said I went through screen after screen after screen for one company. But in this case, I said I'm doing the same thing over and over again, right? So I programmed the AI model to recognize what I would recognize and qualify it the way I would qualify it. And I would run screenshot after screenshot through it. And basically what would have taken me probably a month to go through, I got done in 2 or 3 days.
Yeah. Okay. That's awesome. Yeah, I could see there's, I mean, the difference between someone like you doing that and someone that doesn't know what it should look like on the other end, that could be disastrous. If you just like, hey, give me the data from these screenshots and then just accept it blindly, that could lead to trouble.
Well, even when I was looking at it, is maybe 90% effective.
Mm,
And there are times it would work fine for 2 or 3 screens.
right.
And then all of a sudden I would recognize it missed something or it did something wrong. And that's the value of the human still.
Yeah.
And I would ask it, did you follow my rules? And it would say yes. And I said, okay, here's what you gave me. Tell me how you followed my rules and gave me this answer. And it would answer, because I didn't follow your rules.
Right. Yeah. Yeah. That's the human in the loop difference that most people, or a lot of people I see right now, are not catching. So it can be very dangerous,
Right.
especially in manufacturing.
Well, and in manufacturing, more than just, common stuff, you use the term before, deterministic.
Mm-hmm.
We have to be deterministic.
Yeah.
Because at the end of the day, we can cause machine downtime, or we can cause physical bodily harm to somebody. I
Right.
speak to young engineers a lot. I speak at colleges every now and again, and I tell engineers they have a responsibility. You have to do it right. Our profession is one of integrity, because if we do it wrong, machines break and people get hurt.
Yep. Yeah. When I was working at DuPont, my mentor, when he was talking about the standards that were in place, he's like, most of these are written in blood. He's like, the reason we have these is because of some fatal or near fatal incident. And so it's
I
very
used to
important.
laugh. The Navy has a procedure for everything, and especially on subs, especially in the nuclear world. And before every procedure, there was probably a list of 20 cases of crazy things to not
Yeah.
do.
Right.
And some of them would make no sense, but somebody did it because it's in there.
Yeah. 100%. So last question, what's your favorite customer moment that sticks out in your mind?
I got a current customer that I can't say their name for confidentiality reasons, but I was brought in there and they were running at a very low OEE, operational effectiveness. And they were told that data acquisition was impossible on their machines. And they were looking for quick answers. Hey, what can I do tomorrow to fix this? Right? How can I get more parts out of this machine? And I had several of these lines, and have them around globally, and they're still expanding and scaling them out. And I came in there and I looked at it and I said, we can absolutely get data off these machines. We need to get sub-second data, build the models to understand what's going on, because if you can't measure it, you can't control it. And right now you're guessing. And they believed me. And they funded it, and we did it. Took a couple months to get the data. We sat down with all the stakeholders, created a 10,000 point IO list, I would call it, off this line. Some data as fast as 50 milliseconds. We worked with the vendors to create the data collection system that could support the high speed, high volume data.
Mm-hmm.
And once we put the real time report out of, hey, these are your yields, these are your throughputs, here are your chief downtime contributors, here are your totalization of alarms and when they're happening and why they happened. We saw over the next 3 months, throughput and yield on a high-speed line increase by up to 15%.
Well, that's substantial. So when you say high speed, high volume, what are some like rough numbers?
I would say per second. Let's call it per second on
Okay.
on the line.
Cool. And then when you're going in, you mentioned, going in and getting that data, those IO points. How involved, are you and Axiom in that process? And like, what does that look like at a day-to-day level?
We lead that conversation,
Okay.
because we've been in that battle many times, right?
Mhm.
So if you haven't been there, you can try to do it yourself, but you're more effective bringing in somebody with some experience.
Right.
We try to be agnostic. We come in as process experts, as technology experts, to make sure that you are getting the right solution for your process, for the way you operate. But at some point, we also have to tell you that maybe there are a thing or two that you're not doing correctly that you need to correct.
Right.
So we can put the right process in and then put the right technology on top of it. But we'll get all the experts within a room.
Mhm.
We'll bring in quality in, we'll bring in maintenance, we'll bring in IT, we'll bring in the controls engineers, we'll bring in operators even, and production managers. And we'll sit down and go through the entire line point by point of what's relevant.
Cool. It's awesome. I think that's it.
All right.
Cool, man. Thanks for being here.
Well, happy to be here.